Okay, so the rotation of the part I wanted to talk about, but then that also has you looking at this and addressing this area. So you have to remember on your rotary, the tool is projected from this center axis point, which is right, your x0 axis at this point, out to infinities in the direction of the tool. So what's happening, you're not really getting a gouge. What you're getting is the shaft dragging, and what that's happening is right in these areas, because the tool at this point, when it's coming up right here, even with the Z0 pointing at the X, it's pointing out this way, and you can see that this right here is actually like a straight plunge to get to that. Now, it's not plunging and gouging this, but what it's telling you is you're dragging the shaft part that no longer has cutting flute along these surfaces here when you're doing that. And I think in the simulation there's even a proximity setting that tells you, you're within 0.002 or something. So anyway, that got fixed a little bit by the rotations I did, because when I rotated it in the Y, it was bringing this nose up, which was making that projection come down into here a little more. So first I'm going to show you the rotations and why I did it, and then I'm also going to talk about how I want to fix this, but I posted some questions in the forums about if we can move the model up a bit. I want to actually move this truck. I want to make the rotation axis actually down in here, and what that's going to happen is the truck's going to it's going to be rotating around this point. You'll be setting your 0 in with your stock in here, and so the top of the truck will be like wobble. It'll be like a warble, it'll be going to do. It'll be shorter on this side and longer on this side, but what that's going to do is move that projection down into here, so when it comes up over here, it's actually going to be able to get that whole surface as it points down into there, and I'll show you that in a second. So first, the rotations. Yeah, why did I do that? So anytime I'm on the fourth axis, I want to really make everything symmetrical, and it really does matter, especially with things like that rotary, because of, it's even essentially what I just pointed out. So first thing I'm going to do is I'm going to view it from the right side and see how it's twisted that way. So I'm going to rotate it just 2 degrees in the X, and I'm going to leave the 0, 0 there, so that has it fairly flat that way, right? Now I'm going to look at the Y, which is the front view, and I'm going to see here what, first let me rotate it in the Z. See how the tires are off here? I can see the back tire and I can't see the front tire. So let me look at the top view, first, so Control 1. Did I get it? There. So now I'm going to rotate it in the Z, by 2 degrees. Or no, by 1 degree, I think I said, yeah. So that has a more straight, right, it's almost straight down the middle. When I first did it, I did it 2, and I thought I had it lined right, but then when I did the Y rotation, for some reason I moved it back 1 degree, so I said only 1. So now let's look at that Y view again, which is the front view. And now the reason I wanted to rotate the Y is mainly I started doing it because of this. And then what that's actually even going to help with up here too. So the reason I did that is because when you're indexing it, when you're in the top view, you're going straight down this way. Now you can toolpath that whole thing. But when you're in the bottom, toolpathing up this way, it's not going to go back and undercut. It's going to take from this highest point. Now it's just going to go straight up, and it won't cut anything over here. So really what I want is this surface right here to be vertical, so when I toolpath this side I get it, and when I toolpath from here up I get it too. So I'm going to rotate that in the Y. Hopefully it was 2. I have to remember what I did. There. Now that's pretty vertical. Now I might pay more attention and make sure that that really is vertical, because then I need to be cutting the surface with Z-level finishes, and I don't want it missing the surface because it can't see it from below. And what that does too is it actually helps for the front. When you're coming down and we're going to finish this side, we're actually getting the face here actually more visible up here, and it just helps out with all that. When you're roughing it from this side, it's not going to rough anything in this whole area from this furthest point up. So that's one of the gouge errors you're getting in the front. Not a gouge, but clash errors with stock, because when we're running our finish pass, plunging all the way into this point in here, there's all this stock in here that really you're plunging through with that little flute tool, because from the bottom it's just making a straight tool path up this way when you're doing that roughing, and all this is still full of material. So we're going to address that later. Now, after I made that rotation, get a little closer on the wheels. Yeah, I probably could go a little more in the Z, I think, but that was close enough for me. Now I translated it up because I wanted to keep your part in the stock. So I think I just went up 0.75 in Z, right? 0.75. There. Now your truck remains all within the stock, whereas the rotating before got it out of the stock. So that's going to help with this whole front area, and it's also going to allow us to do this back in our finish passes. And so it looks a little funky that way, but it's more squared up and symmetrically squared up in the stock. See, the center point now is pretty close to that. I mean, in theory I could rotate that a little more, but I don't think that's too far out to do anything. So now I want to show you too also about, I'm going to have to reselect the geometry now that I moved it around, and then we'll compute that tool path really quick. Okay, so now that just that rotation amount even changed that a little bit right there, right? You see how it's now less of it actually got your rotation point down here, because it used to be up here, now it's deeper in here. So that line becomes more of an angle. And so now I want the tool to really read and go to all of the surfaces. I don't want it missing. See how, it's really missing a bunch of your surface. So I want to talk about, I asked in the forum about your Z clearance, about how much room do we have, because this will be the highest point here from this 0. Can we move this up higher? Because what I'm going to want to do is actually change your rotation axis down in the Z. So I'm going to put -4 there now, and I'm going to compute. Now what that's done is it's actually going to now be creating that rotary tool path from a point down in here. So it's going to expect that you're chucked up if you chuck up your 0 point in here, now look, you're even getting flatness here because the rotation point is down here. So I want to measure the full height from that 0 up to here, and let's make sure you have enough. And we might even set it further down, like even if you can set your rotation axis down in here, then that tool is going to get all of this surface. And of course it'll get this easy enough down here because this is just flat, but all these curves, if we can set it even further down, like 10, it's going to be tool pathing all of this in here. Okay, so I was just having some issues with the measurements because all your index systems are they're set from these outer, so like you have a 0 for up here, a 0 over here, a 0 over here. When we set up our rotary, our 0 is the center of the rotation axis. Everything else is a positive number. And then I can measure everything. What's happening now is each time I go to one of your tool paths, all the parameters are I'm gonna have to sit down and figure out the top of part 10, and when I'm changing these parameters, they're all different. So if I can get all the zeros centered up on the 0, then I'll be able to measure properly how high I have, and if you answer your full Z clearance, we could determine that maybe you don't really need that type of tool that you're saying is the only one that'll reach the areas and do it. You might be able to do it with a different ball mill that has a large cutting flute, excuse me, and be able to reach all the areas, excuse me, by changing that rotation point, because really you're just going to have your collet miss all of this stuff. And when you plunge down over here, I mean, how tall is it from here down to how far we need to go to 0 to make both ways? So let's get some of those questions answered. I'd like to reset the model up differently. You might tell me I can't. We'll look at it. Raf's already done some finish work over here. When we determine what kind of tab you're going to put in here to hold it, like I just put that 3mm cylinder, someone might, that might not be sturdy enough to hold the whole part. I haven't really thought about those parts yet, but we could put a square, a cylinder, anything that's going to be sticking out both sides that we don't cut. So, excuse me. So when we make our finished tool pathing here, it's going to have to avoid something that we put in here. Let's figure out what that is. We'll get it in there, and then we can get this thing cut to where it'll cut all your detail. And we have to do enough tool pathing to get rid of all the stock for this finish pass to work properly. Anyway, we'll talk more a little bit later.